Good afternoon to all of you. Welcome you guys. Welcome you all. How we are doing everybody? कैसे हो सभी लोग? I think we are live. So first of all, is the audio videos clear to all of you? Tell me now. Comment करके बोलिए. Is the audio videos clear? Very good evening to all of you. How we are doing everybody? कैसे हो सभी लोग? Audio videos clear to everybody? Fine. Okay then. That's great. So चलिए आज का से हम शुरू करेगा. इसके पहले सो हियर ए ग्रेट अनाउंसमेंट फ्रॉम अनअकैडमी से आपको बढ़िया से बढ़िया ऑफर है. That is now you can start your gate preparation. Gate 2027 का preparation. Just you can start your gate 2027 का preparation just 10,499 only. You can start your Unacademy subscriptions so with the just 10,499 only. So year end sale, that is 55% of discount आपको मिलेगा. 55% of discount आपको मिलेगा. ठीक है. साथ के साथ आपको गेट एश्योर भी आपको मिलेगा. एक मिनट कुछ एक मिनट थोड़ा एक मिनट थोड़ा सिस्टम स्ट्रक हो रहा. अभी चेक करके बोलिए ना हुई है. अभी चेक करो. Now you can see now here. Is the audio videos clear to everybody? First of all, I think now it is clear. Yeah. So you can start your gate preparation. Gate 2027 का preparation just so 10,999 only. And इसके साथ you will get the 2 month extension भी आपको मिलेगा. And इसके साथ gate issued plan भी आपको मिलेगा. ठीक है. So you to enroll for it now, do immediately enroll for this Unacademy. So by using the code of BVREDDY, use the code of BVREDDY and to get the personalized guidance from me. साथ के साथ आपको शॉर्ट नोट, टेस्ट सीरीज सब कुछ मिलेगा. अगर पूरा प्रिपरेशन हमारा गाइडेंस में चलेगा आपका पूरा प्रिपरेशंस. Right. So you can see now these are the ESC 2025 rankers from Unacademy. Yes. And test series we have planned this time. December 2015 onward test series is available. And we started the new batches for GATE and ESC 2028 के लिए as well as 2027 के लिए भी नया batch शुरू हो रहा. The batch is started from the December 27th onwards. And you can have a starter kit is available at the Unacademy stores and you can avail these opportunities. Now इसके साथ we have started a new batch that is West Bengal Electricity Department का batch, नया batch हम शुरू किया. So you can get this batch that is just 3,499 only. Officers call for ESC interview guidance के लिए. And crash course we started is running. Nakshatra batch and Unacademy Una. You can talk to Unacademy Una according to your requirement. That is, there are 3 modes of operations are there: voice mode, quiz mode, smart summaries. Right. And test series, and you can start the test series now seriously. And we are offering the 2 subscriptions. We are offering, one is a plus वाला, other one is a iconic. Plus में आपको क्या चीज मिलेगा? Plus में आपको क्या चीज मिलेगा? You can see. Plus में आपको क्या चीज मिलेगा? Top educators classes मिलेगा, live doubts, evaluated main test series, structured courses, PDF, live quiz, unlimited access. And इसके साथ iconic में क्या extra मिलेगा आपको? पर्सनल कोच भी मिलेगा, फिजिकल नोट्स and ask a doubt feature, and all the doubts will be cleared. Yes, you can start the serious preparation with an Unacademy. We are there to provide the best guidance for you. चलिए आज का सेशन हम शुरू करेंगे. सबसे पहले ना हुआ we are doing a sequential का पार्ट. सीक्वेंशियल पार्ट आप सभी ने ध्यान देने के लिए कोशिश करो. सीक्वेंशियल पार्ट में सो हमने पहले what we can discuss now, flip flops, counters, registers हम डिस्कस करने वाला. ठीक है. So what is sequential circuit? First of all you tell me now. A sequential circuit क्या है? In case of sequential circuit, whose outputs at any instant of time depends on the present input, as well as on the past input also. Depends upon the present input, इसके साथ depends upon the past output also. That type of circuits are called as sequential circuits. हमने previously discuss किया combinational circuits. Combinational circuits में क्या होगा? The output depends upon only on the केवल present input में depend करेगा. But here the output not only depends upon the present input, it depends upon the past output में भी depend करेगा. So obviously past output भी verify करना पड़ेगा. इसके लिए past output भी store करना पड़ेगा. इसीलिए we require the memory is required. In this case memory units are required. And इसके साथ feedback also required. Okay. चले, let's talk about the first the device that is flip flop. Flip flop is कौन सा चीज है? You see this thing here. It's a combination of latch plus by adding some clock signal, which is called as a flip flop. And there are the different type of flip flops are there. 4 different type of flip flops. By modifying the basic flip flop, and we'll analyze a one by one flip flop. We'll analyze it. ठीक है? Yeah. सबसे पहले we'll talk about what flip flop? SR flip flop. SR flip flop. SR flip flop. ध्यान दो सभी ने. So this SR flip flop has a 2 input S and R, and then 2 outputs Q and Q bar. And these outputs, these two are complement to each other. These are complement to each other, and we have a clock signal. Now you can see now here, when the clock is 0, if the clock for the any flip flop is 0, output of the flip flop is always 0. Flip flop does not respond. It will use what? Tell me now, in the previous state only if the clock is 0. For every flip flop, clock is required. If the clock is 0, irrespective of inputs now, if I say agar 0 आए तो 0 आएगा, 1 आए तो 1 आएगा. So I can say this as what? Tell me now, Q we can say. जो पहले हुआ अभी भी वो ही आएगा. So that's why this is called as what? Tell me now here, hold state. What we'll call this as a hold state, memory state, no change, like that we used to call. ठीक है? Next, if this is clock is 1, then only the flip flop will respond for the given inputs. If S is equal to 0, R equal to 0, both are 0, that means what is the situation of a flip flop is that is in hold state. Hold ka matlab is what? Tell me now, whatever the previous value, now also same thing. Previous value, present value same. पुराना output और फिर से repeat होगा. Now S is equal to 0, R equal to 1. That means what happens? S value 0, R is 1. What is the R stands for? Reset. Means reset button. Reset is activated but set is not disturbed. Reset is activated. Then क्या होगा? You tell me now. When you press the reset button, what happens to the output of a flip flop? Will become 0. Okay. Then we can call this as what? We will call this as a, this will call it as a reset state. What we can call this as a reset state. If the R equal to 1, so reset is activated. Just imagine when you press a reset button, what will get now? So we'll get the other output of the flip flop will become 0. Next, 1, if S is equal to 1, R equal to 0, क्या होगा? You tell me now. Which pin is activated? Set pin is activated. If the set pin is activated, what happened to output? You tell me. So here set pin, it will becomes 1. 1. We'll call this as what we can say now, set state. What we'll call this as a set state. If both are 1, just imagine now here, when you press the reset button, so system reset करेगा. Reset का मतलब is what? Tell me, all the values will become 0, 0, 0, 0. When you press the set button, the system will be set बनेगा. Set का मतलब is 1, 1, 1. All output of the flip flop will becomes 1. So just imagine now, अगर एक साथ दोनों press किया तो, when you press the both are simultaneously, क्या होगा? Have you ever tried this thing here? दो बटन you have pressed simultaneously, एक साथ press किया, then क्या होगा? Then system पागल बनेगा. हाँ ना बोल, system पागल हो जाएगा कि नहीं? So in this case, in this case, what we can call this is now here, this is output is invalid. We can say random output will come. It may be either 0 will come or 1 will come, random output will come. This is called as an invalid state. All of you? Chalo? Next. Now let us talk about the characteristic table. Characteristic table. Now this assuming always clock is 1. If the clock is 0, what happened? Hold state banega na. Assume the clock is 1. Now you tell me now here. I have taken the inputs now. S is equal to 0, 0, 0. 0, 0, 1. 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. Right. Now you tell me now here. So you see this thing here, output now. So here S is equal to 0, R equal to 0. When both inputs are 0, what is the state of the flip-flop? You tell me. It is a hold state. Hold ka matlab is what? Tell me now. Jo previous value, now also same. Previous value, this is 0. So now also 0 only na. If it is 1, what happens now here? So here, so now also 1 only. S is equal to 0, R equal to 0. That is a hold state. Now you tell me now here 0, 1 ke liye. That means what happened now here? Which is activated. Reset button when you press, क्या होगा? पूरा system reset होगा. 0, 1. Reset button is activated. Next 1, 0 में क्या होगा? You tell me now here. Set button when you press. Set button press किया तो output will becomes 1. 1, 0 set button. 1, 1 के लिए क्या होगा? Tell me now. We'll get some invalid state. 1, 1 केस क्या होगा? We'll get some invalid state मिलेगा हमको. So can you tell me the min terms here? So this is Q plus of S comma R comma Q. What will come? You see this thing here. We'll get the min terms are what you see this thing here. We have this is 1 comma 4 comma 5. इसके साथ we have a two don't cares also there na. That is 6 comma 7. These are the don't cares. Now I need to find the equation for it. For it we'll form a K map. I can able to form it. K map. Now this is S R Q. So this is S bar and S. This is R bar Q bar. R bar into Q. This is R Q. This is R Q bar. So what are the min terms given? You see, we have 1 is a min term. Next, we have 4 is a min term. 5 is a min term. 6 is a don't care. And so 6, which is a don't care. 7 is also don't care now. Now let's try to group them. I'll group this thing now. If I group this thing here, हमको क्या मिलेगा? You see this thing इससे हमको yes मिलेगा. I'll group this also. by grouping this thing here हमको क्या मिलेगा? You see this thing here, R bar into Q मिलेगा, isn't it? Finally, what I will get now, you tell me now here. This is Q plus of S comma R comma Q, which will come it as what I will now, S plus R bar into Q. Okay, and this is the characteristic equation of SR flip-flop. And do remember, this equation does not applicable if S is equal to R equal to 1. Keep in mind, not valid if S is equal to 1 and R equal to 1. This equation not valid. Characteristic equation not valid. Okay. Next, now let's talk about this excitation table. Excitation table means what will be ना, output से input find out करना. 0 0 0 1 1 0 1 1. Tell me now excitation table में, so that's when the output will change from 0 to 0 case. You see this thing here. Here we have a 0 to 0 transition is there na. Here also we have a 0 to 0 transition. In this case, how much the S value 0, R value here it is 0, here it is 1. So from this what I can say now, S value both cases is 0, but R value is what I can say don't care. So we can say this as what I will now, 0 cross don't care. Okay. 0 cross don't care. Now you tell me now, when we have a 0 to 1 transition, you check it. 0 to 1 transition, which cases we have? 0 to 1 transition. In this case, we have 0 to 1 transition. Now only one this case. S value 1, R value 0. S value 1, R value 0. Next, 1 to 0 case, you tell me. 1 to 0. 1 to 0. In this case, you see this thing here, 1 to 0. S value 0, R value 1. S value 0, R value 1. Next, 1 to 1 transition, tell me. Where we have 1 to 1 transition. In this case, 1 to 1 is there. In this case also 1 to 1. In this case, S value don't care, R value 0. S value don't care, R value 0. Okay. Now the state diagram. Now here you can see now here Q value, which I am calling this as 0, and here this output which is equal to 1. So you can see this thing here. We have 0 to 0 transition. Initially we have a 0 to 0 transition. When it happens now, 0 से 0. When it is happens, you see this thing in this case. How much the S value, tell me now, 0. And R value is how much, you tell me now, don't care. Next, 0 to 1 transition. 0 to 1 transition. S value 1 and R value is 0. Next, 1 to 0 transition. 1 to 0 transition means S value 0, comma R value is 1. 1 to 1 transition. 1 to 1 transition. S value don't care, R value 0. Okay. This is the state diagram of the S star flip-flop. Next, the drawback of SR flip-flop is what tell me now here. The presence of invalid state. When we have invalid state, when S is equal to 1, R equal to 1, the output is invalid. That is a drawback. Because of that, it leads to the problem called as a critical race. Okay. This is the problem. Next. Now let's talk about the modified version of JK flip-flop. JK flip-flop is nothing but updated version of a SR flip-flop. SR flip-flop में problem है ना? What's the problem of SR flip-flop is a presence of invalid state. That invalid state is eliminated in the JK flip-flop. Let's see how it is eliminated. Here I have taken SR flip-flop only main circuit, and in addition to this we have taken some two AND gates we have considered that you need to observe here, and the two AND gates are connected. Okay. Now obviously when clock is 0, what will be the state of the output, you tell me now? And that is in the hold state. If the clock is 0, irrespective of the inputs, it is in the hold state only. Now let's talk about this thing. What happens now? Clock is 1. So J value is given as a 0. K value given as what? Tell me now. 0. Okay. So we are assuming this value, it should be equal to 0 consider here. So this value is 1. Okay. So you can see now here what will come here. In this case directly we identify the equation here, which is connected to what element of Q bar is connected. Here what we have connected, Q connected now here. Here what will come here, J into Q bar. Here K into Q now, tell me. Okay. Now, so you see this thing, what is connected to S, you tell me. What is connected to S? For S, what we have connected, you see this thing here, J into Q bar. And for R, what is connected, you tell me now here, K into Q. We know the characteristic equation of a SR flip-flop. What is the characteristic equation? Q plus, which is equal to what, tell me now, S plus R bar into Q. So Q plus, which is equal to S is equal to what, tell me now, J Q bar plus K Q whole bar into Q. So Q plus, which is equal to J Q bar plus K bar plus Q bar into Q now. So we'll come it as what, tell me now. This is J Q bar plus K bar into Q. This is the expression of the JK flip-flop, you see. Now we'll understand this thing here for different type of inputs. What I will get this output, we'll see. For different inputs, we'll see the output now here. Now you tell me now, if J is equal to 0 and K is equal to 0, tell me now what I will get my Q plus, you tell me now here. J0 means will come it as what, tell me now. So this value 0 plus what, tell me now, Q. That means we'll get this as the Q will come. If J is equal to 0, K is equal to 1, tell me what I will get. So Q plus, which is equal to what, tell me now. J value 0. Okay, we'll place it now. J value 0 means first term 0. K value 1. So then in this case, what happens now? Second term is also 0. So we'll come it as what element of 0 banega? Yeah, if J is equal to 1, K is equal to 0, then tell me what I will get. So Q plus, J1. So that means this is 1 into Q bar. That is 1 into Q. So we'll come it as 1. J is equal to 1. K is equal to 1. In this case, what I will get now here? Q plus is a J1. So that is Q bar plus 0. So we'll come it as what I will now? Q bar will come. Now see the things now here. Different cases we have seen. Different input combinations we have seen the output now here. When J0, K0, what is the output? You tell me now. Q is equal to 0. Yes, in this case. So we have this is what? Tell me now here. So we are getting it as Q. J0, K1. So we are getting the output as 0. 1, 0, we are getting it as 1. 1, 1 case, what I am getting, you see this thing here, Q bar. Dekho all of you. Okay, so you observe the JK flip-flop का truth table, SR flip-flop का truth table. Everything is same except the last one. You see this thing. Everything is same except the last one, 1, 1. In case of SR flip-flop, when you have given 1, 1, we have invalid state. But here we have a Q bar is there now. Isn't it? So the JK flip-flop is nothing but modified version of SR flip-flop. Isn't it? समझ में आया this time? Now onward, JK flip-flop means we can consider as like this. So this is the JK flip-flop. You can have a look at now. JK flip-flop, JK Q bar. You tell me now here. What will be the output now here? When clock is 0, what I will get? You tell me now. That is a Q only, hold state. That is hold state. If the J1, J0, K0, then that is also hold state only na. Next, J0, K1. K1 means what? Tell me. It is K is similar to like an R. R is 1. Then that means क्या होगा? Reset बनेगा. Then it is reset. Next J1 K0. That means what? Tell me. That is a set करेगा. That is set होगा. When both are 1, 1, क्या होगा? You tell me now. This is Q bar will come. What we can call this as a toggle we should call. What we can say? Toggle. Toggle means change. So previously 0 आई तो now 1 बनेगा, 1 आई तो 0 बनेगा. ठीक है? Next. चलो, let's talk about these outputs now in this case. So previous state अगर 0 एक बार 1 एक बार 0 एक बार 1 एक बार 0 1 0 1. Tell me now output what will come here? J0 K0 means what we can call that as a hold state. Hold का मतलब previously 0, now also 0. Hold state. So this is reset na. Reset का मतलब 0. Reset. 1 0 means set. 1 0 means set. 1 1 means toggle. Toggle means previously 0, now it is 1. 1 1 case toggle. And can you tell me the min terms now? And here in this case of a JK flip-flop, so what are the min terms are there? You see, we have 1 comma 4 comma 5 comma 6. Here there is no don't cares. Now we will form a K map to get the expression. J, K, Q. So this is J bar and this is J. K bar, Q bar. K bar, Q. K, Q. K, Q bar. So you tell me the min terms are 1, 4, 5, 6. Let's group them. If I group it now here, A group से क्या मिलेगा? That is K bar into Q मिलेगा. And if I group these things, this and this, we can group it now. From this group, what will get now here? This is J and JQ bar. Okay. So this is the characteristic equation of the JK flip-flop. What is that one here? Characteristic equation J, K, Q, which is equal to what? Tell me now here. J, Q bar plus K bar into Q. Yeah, that's what we got already. We got. Next. And we'll see the excitation table. Excitation table, ध्यान दो इधर 0 to 0 transition. And how many cases are there? 0 to 0 transition. So here we have 0 to 0 transition. Here also there now 0 to 0 transition. So in this case, J value 0, K value 0, J value 0, K value 1. That means what I mean of 0 cross. So J value 0, K value is don't care. J value 0, K value don't care. 0, 1, 0, 1. See here how many cases we have 0, 1 situation. 0, 1, 0, 1. In this case, so 1, 0, this is 1, 1. J value 1, K value don't care. J value 1, K value don't care. Next, 1, 0, 1, 0, how many cases? 1, 0, here 1, 0, here also 1, 0. So J value don't care, K value 1. J value don't care, K value 1. Next 1, 1, 1, 1. This is 1, 1, this also 1, 1. So this is J value don't care, K value 0. J value don't care, J value don't care, K value 0. Okay. And you can see this thing here, the state diagram. Now, is it fine now? Right. Chalo, next one. D flip flop. So abhi tak till now we have seen the SR flip flop, JK flip flop, they have two inputs, but the D flip flop has only one input. So what we need to do here? It has only one input now. So this one input, how will be connected? You see. So one input is directly we have connected here. The other one we have passed via NOT gate we have connected. Via NOT gate we have connected. That means inverted input we have connected. Okay. Yeah, you tell me now here. If the clock is 0, then obviously irrespective of the input, that is in the hold state only, Q only. If the clock is 1, see what happens. So clock is 1, then only काम करेगा. So let us say D is equal to 0, D is equal to 1. Let's talk about the outputs. So D value 0, when I have given this as a 0 and this I have given as 1. You tell me now J0K1, then what we can call that as a J0K1, then we can call that as a hold state. Hold ka matlab previously 0, now also 0. Okay. If I say that D is equal to 1, then tell me what happened. D1, this is 1, this is 0. So what happens now? J1 K0, then output is 1 now. Yeah, अगर आपने ध्यान से देखा तो in place of JK flip flop, can I take the SR flip flop also? Yes, we can take. SR flip flop has a problem. What the problem is? Both S and R can never be both are one. Can never be both are one. But here in this case, what happens now here? So that means one input directly connected, other input is inverted form we have connected. So obviously these two inputs never be a one. That's why in place of JK flip flop, even we can use the SR also, no problem. Right. Now let's talk about the characteristic table. So obviously when the clock is 0, irrespective of the inputs, we'll get this output as what terminal Q only will come now. So 1, 1, 1, then only a काम करेगा. So if it is equal to 0, 0, 0, 1, 1, 0, 1, 1. Tell me now here we have 0, 0. The D is equal to 0. So output is also 0. D0 output is 0. D is 1, output is 1. D1 output is 1. So from this, can you tell me the minterms here of a D flip flop? D comma Q, which is equal to what the minterms are? 2 comma 3. What the minterms are? 2 comma 3. 2 means what? Tell me. This is D bar into Q plus D into Q. So we'll take the common, Q common, so we'll come it as Q. Sorry, reverse side out now, sorry. This is D into Q bar, sorry. This is D into Q bar. So we'll take the D common. So what I will get now here, Q plus of D comma Q, which will come it as a D will come. This is the characteristic equation of a D flip flop. Output equal to input only. So that's why the D flip flop is called as a data flip flop or the transparent flip flop also. Data flip flop or the transparent flip flop. Next. Excitation table. Now tell me now excitation table के लिए 0 to 0, 0 to 1, 1 to 0, 1 to 1. Tell me the transitions. 0 to 0 transition. When happens, you see 0 to 0 here. Only one in this case. D value 0. D value is how much? D value 0. 0 to 1 transition. 0 to 1 transition here. D value 1. D value 1. 1 to 0. In this case, D value is what? Tell me now? 0. 1 to 1 transition. 1 to 1. D value 1. Okay. So you can observe easily now here, if the Q plus is equal to D, D is equal to Q plus. If the Q output is 1 means input also 1. Okay, if the output is 0 means input is also 0. So what we can say now? State diagram, tell me. So that is Q which is equal to 0 and Q which is equal to 1. Next, 0 to 0 transition like this. When we have, tell me now here, D equal to 0. 0 to 1 transition. When D value is 1. And 1 to 0 transition. 1 to 0 transition. When D value is 0. 1 to 1 transition. When D value which is equal to 1. Right? Next. Now let's talk about another flip-flop, that is T flip-flop. Previously we have connected the input via NOT gate. Now without the NOT gate directly we have connected. This is the T flip-flop. Yeah, right. So you see this thing here. Obviously when the clock is 0, what happens? Irrespective of the inputs, will get it as what will be a hold state पर आएगा. The purpose of the D flip flop is, the major purpose is, two purpose we have. One is for the register purpose. रजिस्टर का मतलब इज व्हाट टेल मी नाउ हियर, जो डेटा आपने लिखा सो वो डेटा हमेशा के लिए स्टोर करना पड़ेगा, isn't it? So that's why we in the registers, all the registers we use the D flip flops only we use. And the other purpose is to provide the required amount of delay. To provide the delay we use the D flip flops. The two purpose, one is what tell me now, registers designing. Register का मतलब is what tell me now, like your notebook. जो आपने लिखा वो हमेशा के लिए स्टोर करना पड़ेगा, स्टोरेज केस. इसीलिए we use the D flip flops are preferable there. And the other purpose is what tell me now, to provide the calculated amount of delay. So हमको 2 nanoseconds delay चाहिए. So according to that I can able to adjust my flip flop. Only purpose is delay purpose. Now if the clock is 1, then only काम करेगा. So here if the t equal to 0, what happened? If the t equal to 0, if t equal to 0, this is 0 and this is also 0. 0 0 means what tell me now, hold state. Hold का मतलब is what tell me now, previous state only. If the t value is 1, then what happen, you tell me now here, 1 1. This is 1 1 1. So 1 1 means toggle mode na, JK flip flop. So here will come it as what I know Q bar. So from this, what we can say now here? What we can say now here? So here, when the t is equal to 0, Q hold state. If the t is equal to 1, it is a toggle. ठीक है? Now let's talk about this clock characteristic table now here. Obviously, if the clock is 0, irrespective of the inputs now here, जो आपने दिया वो ही आएगा. Clock 1 then only काम करेगा. 0 0 0 1 1 0 1 1. Now you tell me. 0 0, if the t is equal to 0 means that is a hold state. Hold means previously 0, now also 0. 0 aito hold state, previously 1, now also 1. 1 aito that is a toggle state. Toggle means complement na 0 to it will becomes 1. 1 aito that is toggle. 0 ko complement, that is 1 ko complement is 0. Right? Now characteristic equation. Now tell me the minterms here. Q plus of t comma Q, which is equal to what will be? Minterms, you can see this as 1 comma 2. So we can say now t bar into Q plus t into Q bar. So what I can say now here, t XOR with Q. This is a XOR gate. Okay. Now let's see the excitation table. So that is 0 to 0 transition, 0 to 1 transition, 1 to 0 transition, and 1 to 1 transition. 0 to 0 transition. 0 to 0. Tell me now. 0 से 0 means what happens now? When can happen now 0 to 0 transition? Here now. Now here I will tell you the another trick now to identify this excitation table. अभी ने हमने देखा ना. So what is this thing? Output which is equal to T XOR Q we have seen na. Now I need to get the T na. T is equal to simply what I can say Q XOR with a Q plus. अगर ये दोनों को XOR ले लिया तो then T will come. Now you can see now here XOR. Take the XOR now here 0 XOR with 0 will come it as 0. 0 XOR with 1 will come 1. 1 XOR with 0 1. 1 1 0. समझ में आया this thing? Tell me. And state table. Now you can see now here Q which is equal to 0 and Q which is equal to 1. Now you see this thing 0 to 0 transition when happens 0 to 0 transition के लिए T is equal to how much? T is equal to 0. 0 to 1 transition. 0 to 1 transition. T value is 1. 1 to 0. So that is T value is 1. 1 to 1. That is T value 0. Okay. Right, these are the four flip-flops we have seen. Right. Next. Yeah, take this problem. What is represented by the digital circuit given above? Hmm. Yeah, tell me now here. This is Q bar now. This bar, Q bar will come here. And this is Q. So here will come it as A Q bar. And this is what is now BQ. So what is the D you see? So D is equal to AQ bar plus BQ. AQ bar plus BQ. Now you can tell me now here in this case. And this is the D flip flop now. D flip flop right? So what we'll get now here? Q plus, which is equal to D na characteristic equation. So from this Q plus, which is also equal to what, tell me now? AQ bar plus BQ. And which flip flop will have this type of characteristic equation, tell me? Which flip flop will have this type of characteristic equation? Yeah, you can see now SR flip flop का characteristic equation is what? S plus R bar into Q. Yes, so this is not na. JK flip flop is what, tell me? JQ bar plus K bar into Q. Can I compare these two equations now? By comparing this equation, this is Q plus, which is of the form JQ bar plus K bar into Q. By comparing these two, what we can conclude, you tell me now here. So that is A equal to J. And then K bar. K bar equal to B. That means B is equal to, sorry, B bar equal to B is equal to K bar. So from this we can say JK flip flop where A is equal to J, B is equal to K bar now. So what's the option you see? Option C. Okay. Next one. The clock frequency applied to the digital circuit shown in the figure below is 1K. Clock frequency given. How much the frequency they given? 1K. If the initial state of the output of the flip-flop is 0, initial state is 0, then the frequency of the output waveform Q is. Okay. Now let's talk about what is the expression first of all. Okay. So here will come it as this is Q na, and this is Q bar. Again this is Q and this is what element of Q bar. Here what will come, you see this thing Q XOR with Q bar. So that is what you tell me now. Q XOR Q bar, different inputs. This is 1. This is Q na. This is Q. Here Q XOR with Q bar. So different input. This is 0. Mean this input is 0. This input is 1. NAND gate na 0 bar. So this is 1. Okay. So that means what the T is given. You see this thing basically. T given as what element, which is always 1 given, isn't it? So if we see the table, if we form a tabular form, you see this thing in this case, what happens? Now this is T and this is Q and this is Q plus. Now, so this is T. T is always 1, 1, 1. And then here Q previous value, if it is 0, we consider initial value. What will come here? T is equal to 1 means that is a toggle mode na. Toggle ka matlab is what, tell me now here. Previous value 0, now it will becomes 1. Abhi Q value is 1 na. So this is, so the T is equal to 1, toggle karega 0. Next it is 0, now it is 1. 1, now it is 0. अगर आपने ध्यान से ऑब्जर्व किया तो सी द आउटपुट ना हुआ, द आउटपुट सिग्नल which is toggling continuously, you see. For it is toggling na here. Toggle means continuously changing na. So that means how much we can say now, this is the time period of an output if I call, which will be equal to 2 times of a clock. And so that's why output is what, tell me now here, that is f clock by 2. So how much is f clock by 2, which is equal to 1k, that is 0.5 kilohertz. Okay. Point 5 kilo. Next, consider the circuit shown below. The expression of the nested is, and what will be the expression? Now here we have this is Q and this is X is there. So this X NOR gate now. So what will come here? X NOR with Q. And here this is the NOT gate and this is directly passed. So that means what is this? Yes, you tell me now here. X NOR with Q ka whole bar. That is nothing but what I can say now, X XOR with Q. Next, what is this R, you tell me now? X XOR with Q. Isn't it? Tell me. So what is this SR flip-flop? SR flip-flop characteristic equation we know now. That is what, tell me now? S plus R bar into Q. So that is Q plus S is what, tell me now? X XOR with Q plus R bar X XOR, no, 𝐿 na 𝐿 whole bar into Q. That means it will come to be a what? Tell me now here. X XR Q plus this is X XR Q into Q. So will come to be a what? Tell me now. X XR Q into 1 plus Q. This 1 plus anything is 1 only now. So will come it as X XR Q. So what's the option you see? Option B. Okay. Next. Take this thing here. The digital circuit shown in figure works as. How the given digital circuit will behave. Tell me now here whether it is a JK flip-flop, SR flip-flop, counter to 9, so then flip-flops only possibilities. Yeah, how it will behave, you tell me. Here, this is what tell me now Q. So here will come it as X XR with Q. So what the D is going, you tell me now. X XR with Q. We have a D flip-flop a characteristic equation Q plus is equal to D. So that means Q plus, which is also equal to, we can say X XR with Q. Yeah, you tell me now which equation, which flip-flop has this type of characteristic equation. List out all now here. SR flip-flop, characteristic equation of SR flip-flop is what? Tell me now. S plus R bar into Q. And the JK flip-flop, that is JQ bar plus K bar into Q. And T flip-flop, that is T XR with Q. And then D flip-flop, which is equal to D. Now you can observe here this equation and this equation we can able to similar equations now. Let's compare this thing. So this means from this what I can say, this is nothing but T flip-flop where X is equal to T. Okay. Done. Chalo. Now let's talk about the triggering. Triggering का मतलब is what? Tell me now. Changing the control input from one state to other state. One state to other state is called as a trigger. And transition it causes is said to trigger the flip-flop. The process of applying the control signal to change the state of flip-flop is called triggering. Okay. The process of applying the control signal to change the state of the flip-flop. Yes, like we can say to change the inertia of a body, we need to apply some force to be required. Similar to that, so to change the state of the flip-flop, we need to apply some trigger, we need to do it. That is called as a triggering. And there are the 4 types of triggers we have. One is called as a level trigger and edge trigger. And of course, we don't use a level trigger. We'll focus mostly about the edge trigger only we'll discuss. There's some problem is there. The problem of this level triggering is what? Tell me. Race around condition. That's why we don't prefer the level triggering. We use only the edge trigger only we'll prefer. Okay, so positive level trigger, negative level trigger. And we have a, so here positive edge trigger and negative edge trigger. And how will indicate this edge triggering, that we'll see that one. Look at now here, positive level. Level means so some duration, some level we wish to consider level triggering. And here this is a level, positive level. This is positive level and this is also positive level. These are called as a positive levels. So in this range, so here whenever the input is available, output will changes. These are positive level triggers. How will indicate the positive level trigger in the flip-flops? By just a line will indicate. We'll just indicate the line and then there will write it as CLK clock. That means that line is represent that is a positive level triggering. The trigger we applied is a positive level trigger. Okay. And negative level trigger. Negative level means here this part. This is called as a negative level. These are the called as a negative levels. This is a negative level. Okay. How will indicate the negative level? Will indicate the line that is at the end we can place one bubble. The bubble means NOT gate. That is a negative level triggering. Okay. Next. And positive edge trigger. Edge triggering. Edge triggering means what I'll mean now here? Instant. So here you can see now here this part. This is called as a positive edge. Rising edge. Here this is rising now. This is the positive edge. These are the positive edge we'll call. This is the positive edge. This is the positive edge. These are called as a positive edges. Okay, in this interval, so when the clock is changing from 0 to logic 0 to 1, 0 to 1, in this case only we have the output. So the flip-flop will respond for the given input signal. How will indicate this positive edge trigger? So here will indicate with this line. If we write the line, that is only the level trigger. Edge trigger case will indicate with this line. At this end we can use this arrow. That arrow indicate that is a positive edge trigger there. Okay. This clock, this is a positive edge trigger. Next. Negative edge trigger. Negative edge trigger. So you can see this negative edge trigger means whenever the clock is falling 1 to 0, 1 to 0, it is moving down now. This is called as a negative edge. This is a negative edge. Okay. Now you can see now how will indicate now here negative edge, and this is a bubble with this arrow. This is a negative edge trigger representation, CLK. Okay. Done. And you can have a look at now here. In the circuit shown in the figure, Q is equal to 0 initially. When the clock pulses are applied, subsequent states of Q is. Okay. Now see this thing. Next state they ask you to find. Now here they given the connection. J value given as 1 and K value they connected to what element of Q they connected. So initially this value Q plus, initial value given as 0. Okay. And here I can place the clock also. When you apply first clock, you see this thing here. J value 1, K value 0. So when you apply first clock, then what happens now? J1 means which is what tell me 1 banega. Okay. Next. Second clock when you apply J value 1, K value Q. Q means 1. 1 means toggle. Previously 0. Now it will become 1. Previously 1. Now it is 0. And if it is third clock 1. So 0. So this is 1. Fourth clock 1 1. Toggle na, so 0. Fifth clock 1 0. This is 1. Okay. So what we are getting, you see. So subsequent states now here we are getting 1 0 1 0 1 like this we are getting now continuously. So 1 0 1 0 like this. Okay. Next. And you can see this thing here. Now see in this case what they given. Similar type of circuit here also. So to get this output we need to form a tabular form like this. We have to form it. And we need to see the output now here. Here tell me now J value given as Q bar. And K value given as what element of 1. And we need to talk about this output. We should talk now. So they given that initially flip-flop is cleared. That means initial values are 0. And they are asking the what will be the values next continuously thereafter. So this is the clock. When you apply first clock, see what happens. Q bar means and which is equal to 0. This value 1. 0 1. It is what element now here reset na. Second clock when you apply Q bar 1 1. Toggle na. Toggle matlab 1. So next one third clock. So this Q bar means 0. This is 1. That is 0 1 means what element reset banega. Next fourth clock 1 1. Toggle. Fifth clock Q bar means what element of here? This is 0 and this is 1. So this thing like this will happen now 1 1. So toggle, isn't it? Yeah, you can have a look at now. What is the sequence and the output? We are getting the sequences. What tell me now? 0 1 0 1 continuously we are getting or not? So कौन option you see this thing? Option D. So if you observe carefully, we are getting this is 0 1 0 1 continuously happening like this. Okay, so this continuous phenomena, we are getting a 0 1. We have a specific name which to call, these are called as a toggle modes. What we can call, these are the toggle modes. There are 7 toggle modes are there. There are 7 toggle modes are there. So in SR flip-flop 1 toggle mode, JK flip-flop 1 toggle mode, D flip-flop, sorry, JK flip-flop 4, D flip-flop 1 and T flip-flop is 1. Okay. These are the 7 toggle modes are there. 7 toggle modes. Okay. Whenever the circuits are similar to in this form, so immediately you can able to say that what is the output, you tell me now. Output will come 0 1 0 1 0 1 will come completely continuously toggle. Okay. Whenever you can find this type of circuits, so in 7 toggle modes are there. So JK flip-flop has a 4 toggle modes. SR flip-flop, D flip-flop, T flip-flop has each one 1 toggle mode. Totally 7 toggle modes are there. Whenever you can find the toggle mode circuits, the output is what, tell me now? 0 1 0 1 continuously will come. Yes, able to identify this thing. Done now, tell me all of you. All of you do like the session. Do like the session and share to all your friends. All of you do like the sessions. Yes, copy the 7 toggle modes. Right. And so I think all of you are getting the notes. I think all of you know how you will get the notes. Okay, कोई दिक्कत तो नहीं ना notes getting. Notes you will get, I will provide you to all the students. So this is complete notes is available. Complete class notes. You will get now complete class notes you will get. And the next one is short notes. And इसके साथ you will get the DPPs also. So what you need to do here? You fellows, you message me in the Telegram. Telegram, so our group is there. That is BV Reddy sir. BV Reddy GATE. In this, you can join in this group. BV Reddy sir. You can search in the Telegram. You can find these 2 Telegrams groups you can find. Okay. BV Reddy GATE and BV Reddy sir. And so you do message me, then you will get this complete class notes, short notes, DPP आपको मिलेगा. Okay, all the PYQs also. Done. Chalo. Next, now you take this problem. The output of a JK flip-flop is 0. Okay. It changes to 1 when a clock pulse is applied. Okay. The input is. What they're saying here, JK flip flop. JK flip flop output is what? Tell me now. 0. Okay, that is a previous value. Yes, previous value which is equal to, right, initially this is 1. The previous value initially 0. Initially 0. Now they are saying it as what? Tell me now. Now the new output is 1 they are saying. To have the new output is 1, what will be the combinations? We need to see this thing. Okay. So output is changing from 0 to 1. If you remember the excitation table directly, you can able to answer. If not, you can analyze it now here. So so here you see this thing. In this case, what cases will happen? You tell me now. Initially 0. When we have this is 1 0 will get 1 now. Even 1 1 also will get 1 only. Toggle banega. 0 for toggle 1, isn't it? So that means J value how much? You tell me now. 1. And K value how much? Don't care. Okay. चेक करके बोलिए. So what's the option? J value 1, K value don't care. Next. Find the frequency and duty cycle of output. If the clock frequency is 10 mega, when J value, K values are 1, 1. So J value 1, K value 1. That means there is a toggle mode now. So this output I am calling it as Y1. This I am calling it as Y2. So Y1 into Y2 is a final output. So let us draw the clock signal first of all. Assume that this is a clock signal. This is a clock signal. Now, so this is clock signal. So Y1 which is given a positive triggering. Positive edge trigger. Positive trigger. Now you see this thing here. Trigger means what? Tell me now here. Positive trigger. This flip flop, this value will changes continuously whenever the positive trigger is there. So you can see this thing here. I will come this output as initially we have 0. This is Y1. Y1. So clock is there, will come it as output is 1. This will be continued until the next clock has to come. When the clock will come, this will be 0. Now again, until the next clock will continue like this. Until the next clock tak will continue karega. The moment clock will came, this value changes. Toggle na this thing. This is Y1. Now we'll talk about this Y2. Y2. Y2 they given us what type of trigger? You see negative trigger. So negative trigger means when the clock is changing from 1 to 0. 1 to 0 only we have to consider na. Not audible. Not audible. I will try to speak little louder. So now adjusting the settings are not possible, I think so. Okay, now Y2. Y2 is what? Tell me now, negative trigger. Negative trigger means at the negative trigger only it will change the output now here. This value, here we have negative trigger now. Here only will changes. Negative trigger will change. Only the negative trigger only the output value Y2 value will respond. Okay, this is negative trigger and this is negative trigger like this. Okay. Now, am I audible now? This is the Y1 and Y2. Now, what is this? F means what? F means what? Tell me now here. F means Y1 into Y2. F is what? Tell me now. Y1 into Y2. Product of these two. Tell me now what a product will come, you see. And AND gate now. AND gate output. When the output of AND gate is 1, when both are 1. Now in this case, up to here both are 0. Here both are 1. Yes, so it is 1. Both are 1. And this is both are 1, then only output is 1. Both are 1. Here both are 1. Both are 1, then only output is 1. Like this will continue karega. Now you can see the things now here. Now, this is the time period of a clock signal. This is T clock. Okay, they asked him to find what? Tell me now here. Frequency of output. What is the time period of this output signal? You see, if I start here, so this is यहाँ से यहाँ तक ना. This is the time period of a clock signal. Output, sorry, time period of output now here. Time period of a output. This is one T clock. This is another one T clock now. So from this, what I can say now, this is time period of a output signal, which is equal to 2 times of a time period of a clock signal. So that means frequency of output signal, which is equal to F clock by 2. F clock is how much? You tell me now. 10. So that is 5 mega. So frequency of the output is how much? 5 mega. And what else we need to see now? Duty cycle we have to see now. Duty cycle means what? In this total, how many boxes you can see now? 4 boxes. Only 3 times which is off. Only 1 time is on now. So that means what I can say now? Duty cycle. Duty cycle D, which is given as what I can say now? On time by on plus off. That is total. That is equal to 1 by 4. Percentage means we'll multiply the 100 now. So how much is value of duty cycle? You tell me now. 25%. Okay. Got it? Next. What the race around condition means what? In case of all the flip-flop which will experience, there is a continuous race between 0 and 1 to reach the next state. That phenomena is called as a race around condition. Means what? Tell me the output of the flip-flop continuously changes between 0 and 1, 0, 1. And so at the next clock pulse, what will be the output, which is not certain. We cannot able to predict what will be the output. And this phenomenon is called as a race around condition. When the race around condition will occur, if the flip-flops are operating at level triggering, flip-flops are in level triggered, and the time period of a flip-flop which is greater than T clock on, and if the flip-flops are operated in toggle mode, flip-flops are operating toggle mode, in these three cases we have a race around condition will occur. The three condition has to satisfy to have a race around condition. First condition is whatever the flip-flops must be in a level trigger, time period of a flip-flop TPD, propagation delay of flip-flop is less than T clock on, if the flip-flops are in a toggle mode. In these three cases we have a race around condition. Race around condition not only occurs in JK flip-flop, it can happen in all the remaining flip-flops also will happen. S star flip-flop, JK flip-flop, T flip-flop, D flip-flop, all the flip-flop will happens. But the thing is, when it will be occurs, the three condition has to be satisfied. First condition is, so level triggering, operation is level trigger, and then delay, time propagation delay is less than the T clock on, and the flip-flops are in toggle mode. Okay. And how we can eliminate them? So the first thing is by increasing the delay. By increasing the delay of a flip-flop. Increasing the delay of flip-flop, that is not a feasible solution. If the flip-flop delay increases, to get the final output, obviously it will take the more delay. That is not a feasible solution. Yes, this is the remedy for the race around condition, but because of that we'll get the other consequences will happen. That means what? Output of the flip-flop is delayed. So that's why we don't prefer this remedy, and we can go for these two remedies we can use. What are the other remedies? By going for edge triggered flip-flops. That's the reason we don't use the level triggering, we go for always edge triggered only to avoid the race around condition. And other phenomena is by using master slave configuration. In master slave configuration, we use the two flip-flops back to back we have connected, we use. Instead of that, if we use edge triggered, then it will be fine, we can eliminate the race around condition. Okay. Yes, this is the master slave configuration. In master slave configuration, so this one flip-flop which we have given as a, this is the positive level, this is the positive level operation, and this we have given a negative level operation. Then we can avoid the problem. Race around condition is eliminated if we can able to do this thing. Okay. So in this case, what happens now here, if we have given as a, this is my clock signal, if I consider, now, so here master flip-flop, the output of this master flip-flop, this is QM if I say, this will respond in case of a master case only. In this interval only will respond. It will respond only the master flip-flop, in this region only will respond. It does not respond in case of a negative level. Like this we have. Okay. Like this we will have. And if we talk slave flip-flop, it will respond in the negative levels only. In this interval only it will respond. In this levels only it will respond. Yes. So as a result, what happens now here? The 2 times toggling we are restricting only at a time. In one clock duration, the flip-flop will respond only once only will respond. The output means final QS. Slave output is the final output. Okay. In this case, master will respond here slave. Here we have master, here we have slave. Master, slave, like this will happen. Okay. And in case of master slave configuration, master is applied with the input clock and slave is applied with the inverted clock, negative. So out of 2 flip-flops at a time, only one flip-flop will respond and other will not respond. Because of this, many times toggling in a single clock has been converted into one-time toggle. In this manner, we can able to restrict the race around condition. Okay. And even the master slave flip-flop has a 2 flip-flop. It can store only 1 bit of information only, keep in mind. Even there the 2 flip-flops are there, it can able to store only 1 bit of information only. Now let's talk about the conversion of the flip-flops. Now let's see this thing, how we'll convert the SR flip-flop into JK flip-flop. We'll convert the one flip-flop to other flip-flop we need to convert. While doing the conversions, you need to follow. So first of all, which flip-flop you required? Which flip-flop you required? JK flip-flop is required. And which flip-flop you have? SR flip-flop having. This flip-flop is have. I have this flip-flop, but I want to convert into JK flip-flop. Okay. Now, let's see this thing. First of all, we need to see this is, we'll convert. Required flip-flop we'll talk now, first of all. And the required flip-flop is what element now here? Done now? Now we need to minimize and we need to find the equivalent expression we need to find out. So for this, now let's form the true K-map for minimization. And here we are doing for S, here we are doing for R. Tell me now here. So here, and this is J and this is KQ. So we have J bar and J, K bar, Q bar, K bar, Q, KQ, KQ bar. This is J K Q, J bar J, K bar Q bar, K bar Q, K Q, K Q bar. Here you can tell me now here, in this case, min terms are 4. 4 is a min term, 6 is also min term. 1 is a don't care, 5 is a don't care. So we can group it now here. So I will group this thing now. So min don't case need not be grouped. So this value will come to be a J Q bar. Okay, J Q bar. So this is yes. Here 3. This is 3. This is 7. And 0 and 2 is a don't cares. And I can group these two. By grouping this thing, we'll get this R. R is what? Tell me now. KQ. So finally we got S is equal to what I got? Finally we have got the S is equal to JQ bar and R equal to what? Tell me now. KQ. Now we need to implement it. I have taken this one. This is my SR flip-flop. So this is S and this is R and here Q and this is Q bar and I am going using the positive edge triggered. So this is Q and this is Q bar will come. So I am taking one AND gate here. These outputs are connected here like this. And now you see this thing. One input which is connected as J. This is what I know K. Next other input कहाँ से आना पड़ेगा? Q bar से. Q bar means here ना. So this connection will come like this. This. Now this another connection here. Q से. This connection. Yeah, check this thing all of you. And this is a clock signal. So in this manner we can able to implement it. We can convert the any flip-flop to anything we can convert. This is a procedure. So those steps you can see now. So here instead of understanding with the steps, we did the problem so that you can easily understand steps. First what we did now here. So we wrote the characteristic table of the required flip-flop. Okay, thereafter we will match the excitation table of the given flip-flop to required flip-flop. Okay, so first we wrote the characteristic table, thereafter we are matching to required given flip-flop. Whatever flip-flop you have. Thereafter we have simplified. So thereafter minimization and then implementations. Write the excitation equation. Next minimize and implement the logic circuit. Right. In this manner we can do it. This is the way we need to solve this type of problems. Fine. Yeah. And fine. So that's it for today's sessions. In the next session, most probably we have on January 1st, we have a next session. On that session, we'll discuss the registers and counters we'll discuss on the session. Okay. Fine. So here, I think all of you know how to get this material notes and all. And you do message me in the Telegram. I will share the links. Okay then. See you. Bye-bye.